All right. Hey guys, sorry about the delay. This is Robab sir, and বাইরে অনেক fireworks হচ্ছিল, so I couldn't kind of start recording the video. And fireworks are still going on, so you might hear a few during the video, and I'm sorry about that. Right? Okay. So waves, right? This is AS physics waves, and this was requested by a lot of people, so I'm going to cover some of the harder topics, right, from waves. For example, like superposition and interference, path difference, phase difference. We're also going to do constructive and destructive. We're going to learn a bit about Young's double slit, right, a bit of diffraction grating and resonance tubes and cathode ray oscilloscopes. Okay, all right, let's get into it. So first of all, just a little revision on the easier parts. You know, you have your this is one complete wave that you have, right? This is what a complete wave looks like. That's the amplitude, right? That's the one wavelength. Yeah, you know that. So you have frequency, which is in hertz. You have time period, which is 1 divided by frequency. You have your V equals to F lambda. That's velocity, frequency, and lambda is wavelength. Right, longitudinal waves, transverse waves, we know that. Okay, moving on. Yeah, there you go. Those are the fireworks again, right? So, একটা জিনিস যেটাতে অনেকজনের problem হয়, which is time period and frequency, right? So, what exactly is your time period? So this is basically a motor, right? Like this fan kind of thing that I drew, right? So imagine if it goes in a circle, right? So একবার একটা কমপ্লিট 360 ডিগ্রি কমপ্লিট করলো, দ্যাটস ওয়ান কমপ্লিট সাইকেল। ওইটা কমপ্লিট করতে যত টাইম লাগে, দ্যাটস মাই টাইম পিরিয়ড। সো আমি এখানে অলরেডি লিখে রাখছি ইজ 0.2 সেকেন্ডস, রাইট? সো একটা কমপ্লিট সাইকেল কমপ্লিট করতে ইট নিডেড 0.2 সেকেন্ডস। সো এক সেকেন্ডে ও কয়টা কমপ্লিট সাইকেল কমপ্লিট করবে? হাউ মেনি টাইমস ডাজ 0.2 গো ইন্টু 1? 5. 0.2 into 5 is 1 second. এই 5টা আছে না, this is my frequency, 5 hertz. Time period is basically একটা complete cycle শেষ করতে কত সেকেন্ড লাগবে, and frequency is basically এক সেকেন্ডে কয়টা complete cycle any object will complete, right? That's the difference between time period and frequency, and F equals to 1 by T, right? We know that formula. Moving on. Now, superposition niye ami onek para khaitam, right? I used to hate this chapter, and I just didn't know what to do with it, right? So I learned. You can learn too. So here, see, these are two waves. Okay, so superposition is basically just imagine two waves meeting or interfering or interacting, right? এখন interact অনেক ভাবেই করতে পারে. They're waves. But for our syllabus, we learn two main ways in which they interact, which is the constructive interference and destructive interference. What are these? So constructive interference is basically, look at this, right? The black wave, it has an amplitude of 4, and the red wave has an amplitude of 2. So basically, দুইজনেরই amplitude is positive. So they kind of add together to form a resultant wave which has an amplitude of 6. এখানে -4 -2 forms an amplitude of -6. So that's my constructive interference. Destructive interference is the opposite. So this has a amplitude of 4, এটা এরকম করে যাচ্ছে, so it has an amplitude of -2. So 4 -2, and the resultant wave has an amplitude of 2, right? এখানে 2 -4 -2. Right? Now, destructive interference, arekta eta hoy, is like imagine both of the waves are basically the same but going in opposite directions. Well, not going in opposite directions, they're in antiphase. But we're coming to what antiphase is, right? So 2 -2 is 0. So the resultant wave looks like this. Absolutely nothing. Now, if this was happening with like sound, like imagine দুইটা sound wave action দিকে আসতেছে or something like that, if those two sounds, this process is called perfectly destructive interference. That means the resultant wave doesn't have any amplitude at all, right? If this happened with sound, we wouldn't hear any sound at all. If this happened with light, we wouldn't see any light. It would be dark, right? Moving on. So that's what constructive and destructive are. Now, I'm gonna move on to two things, and they kind of go hand in hand. ठीक है sir? Which is path difference and phase difference. What are they? So imagine আমার কাছে একটা wave আছে. This is the path of the wave. Now, whenever a wave, remember this, whenever a wave travels a certain distance, আমরা বলি না যে ওই ওয়েভটা traveled that distance. Like for example, if a wave travels 10 centimeters, we don't say that it traveled 10 centimeters. We express it in terms of lambda or wavelength, right? For example, look at this wave, right? If this wave has a wavelength of how much? Look at the x-axis. It says displacement, right? So eta amader, this is basically one wavelength, right? So if this wave traveled like 0.6 centimeters, right? We would say that this wave has traveled half lambda, because that's basically half the wavelength, right? Half the wavelength, right? If this wave traveled like 1.2 centimeters, we would say it traveled 1 lambda. Imagine if this wave traveled like 2.4 centimeters. 2.4 mane 1.2 into 2. We would say it traveled 2 lambda. Right? You get the gist, right? Phase is basically the same thing, but x-axis you have pi by 2 pi, 3 by 4 pi, and 2 pi, right? Yeah. So we know this, we're familiar with this, like half a wavelength is pi, the whole wavelength is 2 pi, 180, 90, 180, 270, 360, right? Moving on. Now, how do they kind of correlate with each other? Dekhi. So this is basically 0.25 pi or 1 by 4 lambda, right? 1/4 of a wave. This is 0.5 pi or pi both C, 0.25 lambda or 1 by 4 lambda, right? Or 1/4 of a wave. This is 0.5 lambda or half of a wave. This is 0.75 lambda, right? And this is lambda, which is the whole wave, right? Now, this kind of correlates with 90 degrees, right? 90 degrees is 1/4 of the wave. 180 degrees is 0.5 or half of the wave. 270 degrees is 0.75 of the wave, right? Like 3/4 of the wave. And 360 degrees is the whole wave, right? Simple. এখন কথা হচ্ছে, imagine I have another wave. Now this wave can start from anywhere. আমি যদি এই ওয়েভটাকে এরকম করে একদম 0.5 থেকে স্টার্ট করি, goes something like this, right? এমন always remember যে ওয়েভটাকে একদম মানে সেম প্যাটার্নে স্টার্ট করতে হয়. So this is like our second wave. Now watch what happens, right? Remember this? Remember the perfectly destructive interference? See? That's exactly what's happening, right? আমি এটাকে ওখানে একটা কমপ্লিট করে দিই, right? So this is destructively interfering when we're starting from half lambda or 180 degrees. That is why when the path difference, right? What is the path difference between these two? This wave হচ্ছে তোমার already 1/2 lambda travel করার পরে the other wave kind of started, right? It started from here. So ওদের মধ্যে ডিফারেন্সটা কত? Half lambda, right? So when path difference is like half lambda between two waves, তখন they destructively interfere. See, এখানে যদি আমি দিতাম এখান থেকে স্টার্ট করতেছে, রাইট? এখান থেকে যদি স্টার্ট করতো, রাইট? ওদের মধ্যে ফেজ ডিফারেন্সটা কি? Phase difference is basically the first wave start হয়ে 180 ডিগ্রি ট্রাভেল করার পরে সেকেন্ড ওয়েভটা স্টার্ট হয়েছে, রাইট? So that means that ওদের মধ্যে phase difference is 180 degrees. So when something is at a phase difference, when two waves are at a phase difference of 180 degrees, right, they are said to be in anti-phase, which means they're not in phase. তার মানে ওদের মধ্যে destructive interference হবে. Now, moving on to the next one. See, constructive interference between two waves. See, this is how constructive interference looks like. See, the two waves just kind of interfere and then they add up and then form a resultant wave. This is what destructive interference looks like. This is একটু আগে দেখলাম, right? See, 180 degree থেকে শুরু হয়েছে 0.5 lambda থেকে, এইটা শুরু হয়েছে 0 থেকে, right? So constructive interference তখনই হয় যখন whole number value of lambda থাকে, right? Like phase difference or sorry path difference. See, যখন path difference-টা মনে করো 0 থেকে, right? If it started from here, it would constructively interfere. But it started from here, so it's destructively interfering. যখন whole number like 0, তারপর 1, তারপর 2, when the phase difference between two waves is like 1 lambda, 0, 1 lambda, 2 lambda, 3 lambda, or 4 is a whole number value, they constructively interfere. But then, when the path difference is like half lambda, like it was ekhane, see, it started off from half lambda or 0.5, right? See, তখন half lambda, 1.5 lambda, right? This is 3 by 2, sorry. 3 by 2 lambda, 5 by 2 lambda, 7 by 2 lambda, right? Like 0.5, 0.5, 0.5. When destructive interference occurs, তখন দুইটা ওয়েভের মধ্যে path difference is always a fractional value, right? Like half, 1 by 2, 3 by 2, 5 by 2, 7 by 2. Like, see, it's a pattern, right? সবগুলো উপরে odd number, নিচে 2, 2, 2, 2, 2. Yeah. So this is very important, right? কেন? Because যখন we're gonna do sums, তখন আমাদের এরকম sums আসে, and we're gonna see that in a while, right? একটু পরে দেখতেছি, right? এখন দেখি, when two waves constructively interfere, it produces a maxima, right? What is a maxima? Basically, imagine two light waves, right? Intensity দুইটা constructively interfere করলো, and they form a brighter light. That is a maxima. When two waves destructively interfere, it produces a minima, right? এখন কথা হচ্ছে আমাদের সামসে অনেক সময় এরকম আসে where they ask us if two waves are like interfering, will there be a maxima or will there be a minima? So ওইটা কেমনে করে দেখি? So for that আমি একটা example দিছি. This is Greg, right? He is a wave. His wavelength is 2 centimeters. This is Tammy. She is also a wave. Her wavelength is 2 centimeters also. So, remember how I said that when something travels, right? When a wave travels, we don't just say that it's traveling like 10 centimeters, right? Like Greg, the wave, travels like 10 centimeters, right? So we won't just say that he travels 10 centimeters. We'll have to say that he travels 5 lambda or 5 wavelengths, because see, his original wavelength was 2 centimeters. So 10 centimeter কয়টা wavelength হবে? Unitary method 5টা, right? The same goes for Tammy, but Tammy traveled 20 centimeters. Like Tammy is also a wave, right? And her wavelength is 2 centimeters. So 20 centimeters এ কয়টা wavelength হবে? 10টা. She travels 10 lambda, right? Now that we know that, let's see আমরা Greg আর Tammyর মধ্যে path difference-টা কেমনে বের করব, right? Path difference হচ্ছে, when two waves interfere, ওদের মধ্যে যে path difference-টা, or the difference in how much they traveled, right? Path difference-টা, right? Path difference-টা যদি হয় আমাদের like a whole number, 1 lambda, 2 lambda, 3 lambda, 4 lambda, তখন হবে constructive interference or a maxima, right? path difference টা যদি হয় half lambda 1.5 lambda 2.5 lambda তখন হবে destructive interference and a minima, right? So basically we use the path difference to determine what will happen at the point where two waves meet. Will it constructively interfere or will it destructively interfere? So let's see how to do that, right? So Greg travels like 10 centimeters, right? And Tammy travels 20 centimeters. Their path difference is how much do they travel? 20 minus 10. That's 10 centimeters, right? And then we have to divide that with the wavelength of both of them. Now, আমাদের সামসের মধ্যে আমাদেরকে অলওয়েজ দুইটারই ওয়েভলেন্থ সেম দিবে, right? Because the wave will always be coming from one source, right? Or else they can't interfere. One of the main requirements for two waves to interfere is for them to have the same amount of phase difference, or they have to be coherent, right? So ওদের wavelength same. So basically যতটুক travel করছে দুজন, right? Like the second wave travels 20, Greg travels 10, and then we have to subtract it and then divide it by the wavelength itself, and we get 5 lambda. And this is a whole number value. That means they interfere constructively. So it forms a maximum, right? Same ultata dekhi. See, Greg travels 10 centimeters, the other one travels 15 centimeters. So ওদের মধ্যে path difference কত? 15 minus 10 হচ্ছে 5, and then divided by the wavelength, which is 2, that's 2.5 lambda. So this is 2.5, and যখনই কোনো fraction বা decimal value থাকবে তখন it's destructive interference and it's a minima, right? That means at the point where they meet, it will be a minima. এখন কথা হচ্ছে we'll do one more sum with this, right? Let's try this, right? Now this is actually question paper একটা sum. I found this on the question paper, right? So basically what is happening here? So moving apart from silly examples, so this is a speaker, right? And it's emitting sound. So this sound is basically traveling along this line to this point, right? And this sound is also moving edike. Now speaker থেকে তো sound spread out হয়, so it's moving edike. It's reflecting off of this glass surface. Just glass ধরলাম, right? It's reflecting and then coming back here, right? Now a point এসে due to their interference, will there be a minima or a maxima? How do we determine that? Well, basically, first of all, let's find out যে দুইটাই কত দূর travel করছে exactly, right? Like Greg, Tammy, right? How long did Greg travel? So এইটা কত? Now this is a 90 degrees, so আমরা normal right angle triangular formula there we can find out যে this is actually 5 centimeters, right? So if this wave traveled 5 centimeters and the other one, which the one that got reflected, traveled 3 plus 4, 7 centimeters, right? ওদের মধ্যে difference-টা কত? Is 2 centimeters, right? Now what did we do after we found the difference between the distances that they traveled? We divided it with the wavelength, and the wavelength is 0.8, right? Oh, right, so meter, yeah, same shit, right? So 0.8. এখন this comes up to 2.5. Now 2.5 lambda, right? So 2 meter, how many wavelengths are there? 2.5 wavelengths. Now that means that ekhane at this point it's a minima, because as we know, যদি fractional value of wavelength আসে, lambda আসে, তাহলে it's always a destructive interference or minima. So that's how you do these sums, because you guys encounter a lot of sums like these, right? And I remember a lot of people having a lot of problems with these, so I hope it's clear. But if it's still not clear, you can knock me and I can help you out with it, right? All right, moving on. What we are going to do next is Young's double slit, right? Young's double slit experiment. Now, Young's double slit experiment, I'm not going to go into the background of it, but we're just gonna learn like how to do the sums and like just how to interpret the sums, right? So first of all, কয়েকটা part আছে এটা, right? First of all, we have the slits themselves, right? These are the two slits, and এটা হচ্ছে the slit separation or the slit difference, right? This is the difference between the slit and the screen. When light waves basically pass through here, right? First of all, মাঝখানে একটা bright spot আসে, right? There's this super bright spot here. Then একটা certain angle এখানে আরেকটা bright spot আসে, এইখানে আবার এই ডিস্টেন্সটা, this distance and this distance is exactly the same, right? This is called the first order maxima. This is called the zero order maxima. This is also the first order maxima, right? এই zero order আর first order এর মধ্যে একটা difference আছে. What do we use Young's double slit for? We use it to find the wavelength of the light that is coming in, usually, right? And this is basically how it looks when they interfere, but this is like, I mean, perfectly draw korte pare nai, right? So they kind of just like interfere like that. Constructive interference hoy jekhane for zero order maxima, right? See, this is constructive interference, yeah. And destructive interference ekhane, these are basically like dark spots, right? These are called the first order minima, yeah. All right, moving on. The formula itself. The formula is lambda equals ax by d, where a is equal to difference between slits, x is equals difference between fringes or maxima or minima, d is equals slit to screen separation, right? As we see here, right? There you go. এখন কথা হচ্ছে, when setting up the apparatus for Young's double slit, there are a few requirements, right? What are the requirements? It's basically when you're setting it up, see this A or the slit separation, it has to be somewhere around like 1 millimeter, right? It has to be somewhere around 1 millimeter. Keno? Because if we increase this too much, the maxima themselves, they kind of spread out a lot, and the screen is only, it's not that big, right? Usually, like in practical experiments, right? A is approximately 1 millimeter-ish, right? I actually encountered a sum like this, right? Wait, hold on. Let me just show you the sum itself, right? See, AJ, suggest a suitable value for the separation A of the slits in the double slit. AJ, see? A একটা suitable value suggest করতে বলছে, and if you have to suggest one, do suggest like something around 1 millimeter or 2 millimeters, something like that, right? It's very important. Okay, moving on, right?